Welcome everyone. My name is Cristina Puntí Alvarez, and today I will be presenting my work EgoSign, a first-person view dataset for sign language. This is my final thesis for the Master in Advanced Telecommunication Technologies that I have developed under the supervision. Sorry for that, I'm not sure if you can hear it. No, it's fine.
Yeah, it's okay, we don't hear any noise.
Okay, okay, then I will continue. Sorry, I will maybe start over. There's like some back noise. I hope if it's okay, then I will continue. Okay, then I will start over. So my name, as I said, is Cristina Puntí Alvarez, and today I will be presenting EgoSign, a first-person view dataset for sign language. This is my final thesis for the Master in Advanced Telecommunication Technologies that I have developed under the supervision of Xavier Giró and Fernando de la Torre during these last 6 months at Carnegie Mellon University, where I am right now here in Pittsburgh. So during my presentation, I will first start with a quick introduction. I will talk a bit about the background theory needed to understand the project and all the expected outcomes. I will also talk a bit more about the state of the art and all the related materials currently available. Then I will explain how was the project organized, and I will show you finally some results. And also I will go through some conclusions and some future work expected out of this project. So now, without further ado, let's begin with this presentation. I will start first explaining the main motivation that made this project possible. First of all, most of us do not realize it, but currently about 20% of the global population live under some type of hearing loss. And by 2050, this is expected that 2.5 billion people will suffer some degree of hearing loss. That's quite an important number to take into consideration. Then, in addition to that, most available tools that we use every day are not useful for people that cannot hear. For instance, just a simple call that for us it's quite simple, or any type of language functionality such as a translator, a learning tool, are usually not adapted. And for instance, some personal assistance tools such as Siri, Alexa, or Google Translator or Google Home are based on functionalities that most deaf people cannot use. Then, if we keep our attention in these human-computer interaction tools, I am sure you all have heard about the Metaverse that is becoming more and more popular every day. The Metaverse will be some kind of a virtual space, computer-generated environment where we will be able to interact. And similarly, we need to find a way to create this space available for everyone. Then, in fact, there's already a small community of deaf people who are able to enjoy and use this environment. They have somehow modified the sign language by using the controllers of the different VR headsets, and this allows them to interact in this new world. All these features and spaces that I've been talking about give us the possibility to work on new functionalities and have been the main motivation for us to develop this project. And although maybe the overall goal of this project would be to create an end-to-end system for deaf people, in order for them to interact everywhere and with everyone, this is a really difficult task, and we know that. So in this project, what we want to do is somehow contribute in a small part by focusing on the possibilities of sign language in this metaverse. So now, before giving some more details about the project, I will explain you some interesting information that will help you understand what we've been doing in general in this project. First, I will focus a bit about sign language and some important characteristics that are interesting for you to understand all the context. And although it may seem like it, a universal sign language does not exist nowadays. In fact, there are more than 300 different sign languages in the world. And in fact, for instance, in our community, Catalan and Spanish sign language are different. But as surprising as it may seem, even American sign language is different from British sign language. So that's something to take into account. Another important thing to take into consideration is the way that a sign language is translated. So basically, translating from any sign language into a speech is not as simple as it seems. It's not a one-on-one mapping. So basically, you don't have a list of words that you can translate to another and just say, okay, this one is related to this one. The variety is really like stunning. And in fact, for instance, to say hi in sign language, you could do it like this, but also do it like this. So you can see that also there's a lot of different gestures that would make this task even more difficult. In addition to all of this, also there's like a different type of translation used for sign language. This is a textual transcription called glosses. This transcription basically what helps is the signer to know how to sign. And for instance, here you can see that in order to interpret the word Amelia, that it's a noun, they will have to finger spell it, and that's why they put this in front of it. Then most people, and basically this includes me about 6 months ago, usually think that sign language is just moving the hands and that's it, but it's much more than this. Actually, the manual features, of course, the position of the hands and how the hands are moving is really important for sign language, but it's not the only part. In fact, there are some non-manual features, such like the way that the head is moving, how your body pose is, or even the mouth can change completely the meaning of a sentence if you do it one way or another. And in addition to all of this, also the signing context is really important. So I wouldn't be signing similarly here inside than outside or in any other place. So basically now if we focus on sign language and how this sign language would look inside of the metaverse, the more important thing to consider is that although the manual and the context features somehow could be preserved, the non-manual features would be like difficult to use and usually probably difficult to even predict. So what does this mean? This means that somehow we have to give more importance to this manual and the context features of sign language. Another important thing to take into account is that for any type of language processing nowadays, we have a large amount of data. This data is easily collectible and more or less cheap to have. Basically, you can just go to Google or Wikipedia and take an amount of text from there, and it's somehow useful already for you to work with. But the main problem in the case of sign language, and based on all the things that I just said, is that finding a way to understand and work with sign language is not as easy. Basically, the amount of data that we have is small and actually not as good. We face basically different problems. On one side, sign language could be considered as a low resource languages. That this means that finding signers, annotators, or anyone in general with high linguistic studies that can help us in this task is difficult. Also, we face a problem of privacy because not everyone is willing just to be inside of a camera recording something. And finally, also the resources, like even time or money needed in these cases, are limited usually. So with all this information, we can now take a look into the current state of the art of all the work combining sign language and also some type of virtual reality environment. Then before that, I will explain that in sign language, there are mainly 3 different tasks. The first one would be finger spelling. Basically, it consists in trying to identify letters. So they would just go through the different letters. This task is more or less simple because it can be somehow seen as a gesture recognition task. And this somehow has been already studied in some other modalities. Then the second task would be isolated recognition. This could be somehow similar, but instead of just trying to translate a letter, it would be trying to translate a word that it's based on a gesture. But again, it's something that could be understood as a gesture recognition task. Finally, and the task in which we will be basing our project is this continuous sign language translation. And in this case, what we want to understand is the full package. So basically, not only the separate gestures, but the full sentence. And the main problem here is that usually all the gestures are somehow related to the previous one and the following one. And in order to have a full understanding and to know properly how this whole sentence works, makes the task a bit more difficult. Then, in order to assess this problem, in 2021, Amanda Duarte presented at CVPR this How to Sign dataset. How to Sign is a multimodal, multiview American Sign Language dataset that contains a collection of instructional videos that actually come from an existing dataset called How to Dataset. That it's basically videos from YouTube of people explaining how to do several things. This dataset have American Sign Language translation videos and annotation for more than 80 hours. That's quite a lot of time. Also, there are different videos for 10 different categories, and this makes the vocabulary in this dataset pretty wide, and that's why this is a really complete dataset to work with sign language. Basically, my project and this project that I'm presenting here today is an extension of this existing dataset, How to Sign. Then, although this dataset is really complete, there are some important challenges that we have to work on. One of the problems is that some information is lost due to self-occluding. So while you are signing, you could occlude one hand with the other, or the fast movement of the hands, the skin appearance, or even the depth could make us lose some information. And with this new extension of How to Sign dataset, what we want is to overcome some of these limitations. And in order to do that, we will try to improve the hand information. So basically, we will focus on the hands. Then also, we want to keep the existing perspective as an important one, but we also will look through some first-person view datasets in order to understand and explore this new site that we want to add into this new dataset, basically. So we have seen that in general, these type of datasets tackle tasks such as action recognition, detection, or anticipation. And in fact, if we check the ones that are more focused on the hands, we can see that they work on tasks such as hand-object interaction or hand segmentation. And actually, if we go further on and we explore the ones that have some kind of VR or this type of Metaverse type of content, we can see that apart from all these other tasks, they also focus on some type of eye tracking functionalities. Then based on all that I had been explained, I'm presenting here today the work of EgoSign. This is a new egocentric multimodal and multiview dataset for continuous American Sign Language built as an extension of the existing How to Sign. As far as we know, there are no first-person view dataset related to sign language. And with this one, we want to work on mainly 3 different fields of study, of course, sign language, also VR and multiview understanding, and video processing. The idea is basically to record the test and validation partition of the How to Sign dataset, but adding this extra information. So basically what we will do is the signer would use an Oculus Quest headset in order to translate, and from there we will extract some extra information from the hands. Then now I will talk a little bit more about the methodology used to develop all this project. The project could be actually divided in 3 different stages. First, the setup phase, where everything was sort of organized, then the recordings themselves, and also finally a post-processing phase. I will explain first the setup, but before that, it is important to notice that before I was working with this, I did never work with any type of VR headset, develop anything similar. So in general, it was not a straightforward process. So it's something to take into account. So yeah, as I said before, we want to extract more accurate information from the hands. And in order to do that, we use the Oculus headset. In this case, the controllers have not been used. And instead, we only use the available hand tracking functionalities that it's built in this headset. Then when working with Oculus, in general, you need a game engine in order to develop any game. And in our case, instead of developing a game, what we did is create a simple scene that would allow us to show the signer what do they have to translate, basically to show the video that they will have to translate. In order to do that, we chose Unity as a game engine. This would allow us to just track in real time the information that was transmitting from the Oculus into the computer and be able to extract the information in a live mode, let's say. Then, although this hand tracking functionality from the Oculus was supposed to be really good, it turned out to have a minor setback. So basically, when one hand occluded the other, the tracking was lost. Then we actually thought that we were lucky because during the project, about 3 months into it, a new version of this hand tracking was released, that is this one on the right, that as you can see, it's much more reliable and the results seem to be like really much better. But the problem here was that this new version was still not really stable. And by stable, I mean that this functionality did not work all the time. So basically, we tried going through customer services, some YouTube channels, going into different forums, but we did not get the answer on why this was not working. So instead of just stopping there, what we did is basically decide to add an external camera to overcome this loss of information and retrieve the missing information from that new perspective that would be this overhead camera that you can see here, and afterwards you use a post-detection systems in order to track this lost information. Then, apart from knowing how to extract this hand information from the Oculus, we needed to organize all the elements to work together. And initially, we thought about using only one computer, but the computational power needed was too much, and then the frame rate while recording was dropped radically, and we decided to go with two machines instead. And one of them would control all the external cameras, and the other one would control the Oculus themselves and all the things related to it. But what happened when using these two different computers was that a synchronization problem would arise. So in order to solve this synchronization problem, we used several synchronization queues. First, we wanted to make sure that both computers had the same time. And in order to do that, we used an internet time server. We connected to a server here at CMU. And then we also used some visual synchronization cues for the external cameras. I would just turn off and on the lights. And then I would tell the signers to clap and also do this thumbs up gesture in order to synchronize the internal information from the headset with the external cameras. Then finally, all that we needed was a space to make these recordings. And in this case, I set up this green studio space in a lab at CMU. And in here, I had like the different external cameras and also the Oculus connected to the different computers. Then finally, and in any type of research involving external participants and the use of any human research subjects, an IRB process has to be done and approved, and institutional review board must approve the project. And in this case, as I told you, this is an extension of How to Sign, and How to Sign was also recorded at CMU. So that was a good thing for us, because instead of just creating a new process, what we did is apply some modifications into the one that was already approved for the recordings of How to Sign. And this basically allowed us to reduce the time of work put into this from 6 months, that would mean doing it from scratch, to mainly about 2 months. And basically, we applied some modifications on the research involved that it would include me, and also just the use of the Oculus. And in addition to that, when working with any type of research, all the researchers involved needed to finish a course, that in this case was the Social and Behavior Research course, and we did that. Then once everything was kind of ready, we could start the recordings. And basically, the different views that we extracted were these ones. In one side, we had like the frontal and side view that would be similar to the ones that were already recorded for How to Sign. And we added this external overhead view and also the inside of the Oculus. So we would record also what the signer was seeing while they were translating. Then on another side, as I told you, the important part is the hand information that we could extract from the Oculus. And in order to do that, every second we would record the position of the hand, the rotation, and also like the different key points of the hands, of both hands in real time. And all this information would be saved in a TXT file that would look like this. It's kind of insane, the amount of numbers. It doesn't really make sense, but just like every line of material that we had could be translated in some kind of hand similar to this one, that this would be like the different materials that we would use afterwards to train any model or use or work with, basically. Then when making the recordings, I followed the same pipeline for all the videos and just repeat it throughout the different videos. First, I would let the signer watch the videos in order to understand what they were about to talk and to provide a better translation. And then I will let them put the headset on, and I would ask them like, are you ready? And if so, we would start with the synchronization cues, that it's actually what you can see now in the video. I would perform the lining queue, so I would turn on and off the lights. I will run back to the computers, and then I will ask them by showing this image that you can see now on the screen to clap, and then to do the thumbs up gesture. And after that, they would start the translation. You just saw that there was like a small figure in the inside of the Oculus. I would use that because some of the people that came were deaf. So once they put the Oculus on, it was really difficult for me to interact with them. And like this, by showing just a simple picture, they would be able to say, okay, it's my time, let's start, or whatever. Then as for now, we finished this recording part. So this is where we are now in the project. And through the following weeks, the idea is to do this post-processing phase. Some initial and more simple things that we have to do include organizing all the files. I have a bunch of videos, a bunch of files that need to be sorted out. Also cut the videos according to the synchronization cues that I just talked about. Also verify the content of these videos to make sure that the signing is correct. And finally, annotate and label the different videos. On another side, also some other post-processing that will be probably more time-consuming will be using post-detection system on the external camera, so similar to what you can see here, that it's basically extracting the key points with maybe MediaPipe or OpenPost that are just post-detection systems, and then compare this with the Oculus information that we have on this TXT file that I showed you previously. And then with all of these, we will be able to run some baseline problems. First, maybe the easy problem that we see and that we can tackle would be how to align this Oculus information with the information that we extract from the external cameras. Also, we could work on trying to improve the existing results that we have for the how to sign dataset, and try with the topic detection problems or even sign language recognition, and see if adding this information from the hands would allow us to get better results. And finally, we were also thinking about working on some masking problems. So basically just using the hands, see how sign language is understood by only using the hands and masking the face, or the face and the body, and this kind of problems. Then finally, I will now show you some of the results that I obtained through all the recordings and all this project. First, in the written report, in fact, I only talked about the test set, but I was kind of lucky and I pushed the recordings, and this past week I was able also to finish the validation recordings. And in total, I have recorded about 277 different videos using the different systems that I already explained. And here you can see some extra information. For instance, like the size of vocabulary that you can see is kind of wide. And also that in total, we had like about 7 hours of recording videos to work with. Then when making the recordings, 6 different people were able to help out. One of them was deaf, and the other ones were American Sign Language interpreters. In these graphics here under, you can see the amount of videos that each person made. In general, we would plan 2-hour recording sessions, and not everyone would record in the same speed. So some of them would be really fast to work with, and some others not as much. And this is why we have some variance in the amount of videos made by each signer. Then another important aspect to take into consideration when building a dataset is the amount of money spent on it. Each signer would get $30 for each recording hour, and we record about for 28 hours, more or less. And taking into account not only the signers, but also the equipment, also some expenses for me to come here to do this job. The total amount of money needed for this project was about $21,000. And this was made possible thanks to ED and CMU funding. So thank you for that. Then regarding the time, as you can see here, most of the time was spent on actually the setup and just figuring out how Unity works, how the Oculus work, all the problems that we had in between. And actually the recordings that would be like the real outcome, it's a tiny bit of time, but it's interesting to know more or less how this time was like divided. And finally, here you can see now some examples of what I have obtained. As you can see here down, you can see the frontal and side view of the person signing. And then, as explained, there's also like this external camera that you can see on top of the head, where you can see the hands moving. And then also, as I told you, we also recorded the inside view. So basically what you can see here in the left upper corner, it's the what the signer would see inside of the Oculus. These videos may seem like we are losing the hands, but the thing is that as we are working on a 3D space, it's really difficult to record this inside video. And although you may not see the hands all the time, the information of the hands is still recorded. And actually, it's recorded into these files with a bunch of numbers that I'm not showing you, but we have this information. So it's important just for you to notice that although you don't see the hands, they are there. And I will not show the numbers because it's just full, like, in just text files of numbers that doesn't make really that much sense if you just look at them. Then finally, I will now go over some conclusions and some future tasks that we face in this project. Mainly, one of the conclusions is probably the personal growth that I took out of this project. It was really nice to learn about sign language, also about virtual reality and working with datasets. It was something that I did not work before, and it was really, I think it was a really good thing for me. So that's a really good conclusion, I guess, out of this project. Then also, sign language processing is not as simple as any other language. So I guess we have to make an effort in order to help smaller communities to feel as much integrated as possible. And also, of course, this virtual and augmented reality are becoming more and more important. And this means that we have new ways to study and develop new functionalities. So that's a really positive thing also. And finally, and one of the most important conclusions that I take out of this project is that in general, working with any kind of dataset is overrated. So just having reliable, good data, annotated data, all the amount of data that we just use because we have it is not easy. So we have to really, really acknowledge that people that make an effort to have this and that shares this with any one of us in order to do research. Then as for future work, a part of it will be this post-processing phase and all the experiments that I already told you that is expected to be made during these following weeks. But apart from that, there's also some interesting experiment that could be performed in order to understand more how sign language works and these new ways of developing things in the new metaverse and this virtual reality world gives us a lot of opportunities and possibilities in order to just expand the work there. So finally, and before I finish my presentation, I will also like to thank EDI and CMU for the financial support during this project. It would have not been possible without them. And also I would like to thank all my colleagues from the image processing group in Barcelona and of course the human sensing lab here in Pittsburgh. So yeah, basically this has been my presentation. I hope you understand what I've done. Thank you so much for being here. And if you have any question, I will gladly answer them. So thank you.
Thank you, Cristina.